Let's say that we are sending from our browser to a server HTTP request to receive the HTML file. But this connection is not secure because the HTML file that we are receiving, it might be intercepted by the third parties if especially it contains some personal information about the user and so on. It's not a secure connection. In order to make it secure, we are using HTTPS. It stands for the secure HTTP. And instead of port 80, we are using port 443. But the purpose of this video is to go over what are the exact steps for the HTTPS connection. The first step is that we are using is a TCP handshake. So what's that mean? In order to connect to another, let's say from our computer to another computer or from our machine to another machine, we need to establish an IP TCP connection. So for that, we are using a TCP handshake. In the TCP handshake, what we do is first we are sending a TCP SYN request, which stands for the synchronization. It basically starts the connection with the server and asks the server from the client side. We are asking, okay, I want to talk, so I want to connect with the server. And then in response, server, if the server is active, server send another TCP request to the response to the client that, okay, with the TCP SYN and ACK, it acts that, okay, I'm ready to talk. So after that, what the client does is client also acknowledges that, okay, it received the ACK from the server, and now both client and server are ready to exchange the information. So for that, we are using a socket connection in order to connect from the client to the server. Now that's the first step is completed, right? But now let's see the details, how exactly it's done. So for example, here, let's say we are using example.com, and from our machine, we are sending a request TCP connection to the server, and from the server we are receiving ACK, and we are sending back ACK to the server to establish the connection. Now the first step is completed. Now what we have is we can start to exchange the encryption keys. So for that, we are using two protocols. The first protocol is that the secure socket layer. It's an older version. It's mainly deprecated. Nowadays, we are using TLS. For the TLS, we have a 1.2 and the 1.3. We are mainly using 1.3 these days. So it's a modern secure protocol replacing SSL. So what are the purpose of this? What's the purpose of the SSL, right? As I mentioned, that it's a secure way how you can exchange the encryption keys. So both of the client and the server, when they are exchanging a data, they can encrypt that data and send from client to server, and vice versa. So what we do as a part of the TLS handshake. TLS handshake, the first thing is that we acknowledge that, okay, the first step is completed, TCP handshake, so which means that we have connection now. Now we can start to TLS negotiation. So for that, the first request that the client sends the hello message containing containing this information. It sends the information about which version of the TLS it supports. So for example, it's usually 1.3, and it sends the supported cipher suite. So what's that mean is, so which algorithms is used by the client, right? Which algorithms clients can use. So because different web browsers may use the different algorithms, and the different algorithms might be part of that server by the default. So then also another information that the client sends the random byte for the generation of the SNI. SNI stands for the server name indication. The next step is, well, let's see, right? Before going to the next step, let's see how exactly that happens. As you can see here, if we look at at the detailed level, so what we are doing is from our client side, we are sending a request to the server, and we are sending the TLS version, we are sending the client hello, and we are sending the cipher suite. So for example, the algorithms that we can use, for example, here we are listing the algorithm that we can use, and also the server name, right, where we are sending the request. So the next one is, what's the next step? So after server receives that request, so what the server does, server chooses the cipher and the response with the server hello back to the client, and it also sends the certificate and the server hello down. or encrypted extensions, so one of these. But the most important part is that the certificate, certificate that the server sends to the client. So certificate contains two parts. The first part is it contains the public key that the client will use, and it also contains the certificate authority. What's the certificate authority? Let's say that the client has a certificate, right? Client send that certificate to server, has a certificate. Server sends that certificate to the client. It's basically client's ID, server's ID, right? Server send the ID to the client, but the client cannot just take the ID, right? What the client should do, client should verify from its side that, okay, the certificate that is sent by the server, it's a trusted certificate, and it checks in the list of the trusted certificate whether or not that certificate is truly authentic certificate. So for example, a perfect example would be that, let's say, server has an ID and the server sends the ID to the client, and the client checks that ID, verifies that ID. Usually it's used the digital signatures in order to verify the certificate authority. So for example, if we look at again at the detailed level, they agree on what the server sends to the client. It sends the TLS version, it sends the certificate, and it sends the issuer. So one of the issuer of the certificates is the DigiCert. One of the widely used issuer is the DigiCert, and the client from its side, using the public key, verifies that that certificate indeed is authentic. Next step is a key exchange. So what we do as a part of the TLS framework, we are from the client side, we are generating the key material for the pre-master secret, which is that for TLS version 1.3, and the actual pre-master secret itself for the TLS version 1.2. So after that, we are encrypting that material, that pre-master secret that we have generated. We are encrypting that using the server's public key that the server shared with the client earlier. After that, client sends the encrypted payload to the server within the client key exchange handshake message. And after that, the next step is server takes that message, server decrypts that payload, and using the private key. And then the next step, both parties using the decrypted key material and the random values exchanged in the client hello and the server hello, both sides independently derive the same set of the symmetric session keys. So what we did here, right? So we used both algorithms, asymmetric and the symmetric algorithms as a part of the TLS framework, right? So first, using the asymmetric algorithm, we have with the public key, we have encrypted pre-master secret and the share with the server, and the server decrypted that using the private key. And then we have both parties generated the key, which is used as a part of the symmetric encryption algorithm in order to exchange the messages. But why we are using the same key for the encrypting and decrypting message, and why we are using the symmetric encryption algorithm? The reason is that the symmetric algorithm is faster, and if we are sending a lot of data back and forth, so in order to not to spend time on the encryption and decryption, we are using symmetric encryption algorithm. So as you can see here, we are we are sending from the client to the secret, encrypted pre-master secret. So we are first generating that and then encrypting that and the sending to the server. So in the next step, so what we have, right? So we are sending the change cipher specification and finished message, which is indicating that, okay, now we have finalized our TLS. Now we have finalized our TLS handshake. Now we can send messages securely from the client to server and from server to client. Client will, when the client sends the secret, client encrypts that message using the key, and using the same key, a server will decrypt the message and vice versa. And the key itself is never shared. The key is generated on the client side and the server side independently based on the pre-master secret that we have shared in the previous step. So as you can see here, so we are sending that the cipher specification finished, which means that the TLS handshake is finished. Now we can securely send the data. And the next step, we are just exchanging the data from the client. So for example, when we are sending from the client to the secret, we are encrypting the data and sending to the server, and the server decrypts using the same key. So as you can see here, that's how we are sending data, right? So using the key, session key that we have generated in the previous step, we are sending a request from the client to the server and the vice versa. So what happens at the end, right? At the end, when our TLS session is expired, so we are also sending the connection termination, which is that the last message that we are sending as a part of the TCP handshake. So either side is sending the TCP FIN to gracefully close the TCP connection. So as you can see here, either server or client can send the same TCP message, FIN ACK, which means that the connection is finalized. Now another question that we have is that do we perform all this? So we performed a lot of handshakes here, right? So first we opened the TCP connection, and then we performed the handshake, and based on after establishing connection between client and server, we performed the TLS handshake, and we exchanged the private key, and both sides generated the session key, and after that we started to exchange the messages. But do we perform all these handshakes for every request? The answer is no, not for every HTTP request. For example, let's take this case. Let's say we have an example.com, and we have 3 endpoints where we are fetching HTML, CSS, and the JavaScript. So we are performing these handshakes only once in this case, and then for all subsequent requests, we are sending using the same session key that we have generated. So all those cases, for all those 3 endpoints, we are using the same TLS session as long as the TCP connection stays open and the session hasn't expired. And besides that, the modern browsers, they are using the HTTP2 or the latest version of the HTTP3, which multiplex many requests in one connection, meaning that in one TLS handshake. So to sum up with what we have learned here, right? We have learned that in order to send the message securely as a part of the HTTPS request, what we do is securely send the message over HTTP. So what we do is we are using HTTPS, which basically stands for the secure HTTP, and the first step of it is the handshake. So we are performing TCP handshake, we are establishing connection, then client sends hello, and then server responds hello also, and shares the certificate, which contains the certificate authority and also contains the private key. Then using the asymmetric algorithm. So then what client does is client generates the secret and shares that with the server using the public key that it has received in the previous step. So after that, we are sending a change cipher specification. So basically, we are letting know that the parties that TLS handshake also completed, and after that we are using a symmetric algorithm. We are exchanging data between client and secret, and at the end, when we finished our exchange, then after that what we do is either party can send one more handshake to the client to the server, or server to the client, that the TCP connection is now closed. So that's for the HTTPS, but we have one more protocol that we are using and which follows the same guidelines. Let's take a look at that also. So we have SSH, or a secure shell. Let's say that we have a server, and our server is running on Linux, and we want to send a request and we want to update our server remotely, right? Let's say that we want to send a request to a server, we want to open a connection with the server secure shell, and we want to update the application or send some command to the server. So what we do for it, we are using SSH or secure shell. So a secure shell, if we look at that, it's exactly following the same strategies, exactly the same points, exactly the same steps as the HTTPS. So first what it does is it establishes TCP connection, performs the TCP handshake, then they exchange the key, And the only difference between these two, the only difference between the HTTPS and the SSH is that the SSH is using, for the authentication, SSH using the password and the username and the password, and also SSH is used for just sending encrypted terminal commands, and mainly. And also another difference between them is that the SSH, if we establish SSH connection, so we are usually using that for longer time than we are using HTTPS sessions, right? Because HTTPS sessions short-lived. Usually we are sending several requests, and after that we need to open new TCP connection. But in case of the SSH, we are opening the connection, and that connection is active until we haven't terminated that manually.